3:42 a.m. local time. The Persian Gulf appeared motionless, a sheet of black glass beneath a sky without moonlight. Oil tankers followed prescribed shipping lanes. Civilian traffic feeds displayed routine patterns. Along Iran's southern coastline, navigation lights blinked with familiar regularity. Nothing suggested disruption. Then the radar display began to lose density. It did not crash. It did not go dark. It subtly thinned. Within hardened command facilities along Iran's southern air defense arc, operators observed minor irregularities across auxiliary screens. A merchant transponder returned, stuttered. A cargo aircraft briefly disappeared from one sweep before reappearing moments later. Maritime identification signals lagged by fractions of a cycle. Individually, insignificant. Collectively, synchronized. At 2:58, approximately 180 nautical miles offshore in international waters, 2 U.S. guided missile destroyers received a compressed authorization packet via encrypted satellite burst. There was no public declaration, no visible shift in formation. At 3:01, their vertical launch cells unlocked. Tomahawk cruise missiles rose in controlled sequence, exhaust flares briefly lighting the decks before the weapons angled downward, skimming toward the Iranian coast at low altitude. Their trajectories bypassed the main objective. They sought sensors. Within 4 minutes, 6 coastal radar installations along Iran's defensive belt were struck. Antenna structures collapsed, control stations ruptured, power distribution lines severed. Data relays went silent. Inside Iran's Integrated Air Defense Command, the response was procedural, not emotional. Redundant radar units powered on. Mobile arrays transitioned from standby to active. Fiber-linked circuits rerouted through inland command hubs. Doctrine had anticipated outer layer suppression. The systems destroyed were not central nodes. By 3:08, a functional air picture was restored. Primary defensive architecture remained operational. That was the expectation. At 3:10, 4 F-35C Lightning II fighters departed a carrier well outside immediate missile range. Their ascent was visible by design. External munitions increased radar signature. They were intended to register. Deep within a granite mountain complex in the Zagros range, publicly designated as an industrial research site, but functioning as a hardened command center for advanced missile integration and unmanned strike coordination. Operators tracked the inbound aircraft. The facility represented nearly $2.9 billion in excavation, reinforcement, and layered defense. Blast doors measured in tons. Independent turbine generators supplied power. Fiber optic cables ran 10 meters underground. Outer defense rings incorporated S-300 PMU, 2 systems, Bavar 373 batteries, and mobile short-range interceptors concealed in valleys. It was engineered to withstand kinetic assault. At 3:14, passive infrared arrays mounted on mountain ridgelines began tracking the approaching F-35s without emitting radar energy. Iranian commanders maintained electromagnetic silence, waiting for optimal firing parameters. The outer layer had been engaged. The fortress remained untouched. At 3:16, engagement radars activated. Multiple fire control systems illuminated the night in coordinated emissions. Missile canisters opened. Long-range interceptors launched from concealed sites, accelerating toward the American formation. Within the U.S. command network, detection was instantaneous. An E-3 AWACS orbiting at 32,000 feet registered the radar surge. Data streamed across encrypted links connecting fighters, destroyers, and electronic warfare platforms positioned at the edge of the battle space. The F-35s were not the decisive blow. They were the catalyst. At 3:18, as Iranian operators concentrated on tracking the inbound fighters, a separate aircraft far to the south adjusted its vector. To standard radar profiles, it resembled a civilian business jet, maintaining lawful altitude and course. Its identification did not correspond to commercial schedules. It was an EA-37B compass call. While interceptors climbed toward the F-35s and defensive arrays saturated the sky with targeting emissions, the actual axis of attack initiated. The objective was not the granite mass above, it was the digital lattice beneath it, 0319 local time. Iranian missiles closed on the four F-35s, guidance systems refining trajectories through active radar beams. Inside the American cockpits, threat warnings intensified. Visual symbology shifted red. The pilots held formation. They were awaiting a precise cue embedded within the mission timeline. They waited for the release window calculated down to the second. At 3:19:22, all four F-35s broke formation in a synchronized defensive split, pulling high G turns while dispensing chaff and flares into the radar-saturated sky. The maneuver forced the inbound interceptors to adjust mid-course guidance and commit to updated intercept geometry. That commitment was the hinge. At that exact moment, the electromagnetic environment destabilized. The EA-37B compass call sign Phantom Echo, shifted from monitoring posture to full-spectrum engagement. Its AESA arrays did not flood the spectrum with indiscriminate noise. The attack was patterned, frequency-aligned, phase-synchronized, timed precisely to coincide with Iranian radar uplink refresh cycles. Mid-course guidance signals met structured interference. Two incoming missiles began reporting positional inconsistencies. Their telemetry feeds still displayed valid target vectors, but error margins widened subtly. Inside Iranian control centers, nothing appeared catastrophic. Target icons remained active. Engagement radars painted steady returns. Yet minor distortions emerged. A 200-meter intercept drift. A fractional timing, desynchronization between optical confirmation and radar lock. Valid data, misaligned data. At 3:20, onboard safety protocols triggered in two interceptors after their guidance logic flagged irreconcilable trajectory variants. Both self-destructed. The remaining four missiles pressed forward but with degraded kill probability as the F-35s accelerated beyond optimal engagement geometry. Iranian commanders identified the source of disruption. Passive triangulation converged on an anomalous emitter south of the primary battle space, the aircraft presenting as civilian traffic. At 3:21, a reserve S-300 battery that had remained dormant powered up. Its engagement radar cut cleanly through the dark and locked onto Phantom Echo. Four 48N6E3 missiles launched in disciplined sequence. The EA-37B was not designed for afterburning escape. It lacked the thrust envelope of a strike fighter. Its survival depended on precision inside proximity. Within the aircraft's electronic warfare compartment, 7 operators tracked live signal architecture flowing from the mountain facility known in U.S. planning documents as Site Meridian. That facility was the objective. Its defensive network relied on buried fiber infrastructure, air-gapped from open connectivity, and shielded against conventional cyber penetration. Yet no system operating at high frequency escapes physical law. Every processor radiates faint electromagnetic residue. Every hardened interface leaks microscopic emissions. Earlier, an RC-135 rivet joint had cataloged those emissions from standoff range, constructing a signal map of internal synchronization, pulses, and routing intervals, a clock signature invisible to routine detection. At 3:22, Phantom Echo executed the decisive phase. Altitude decreased to 36,000 feet. Transmission shifted from suppression to insertion. Directional bursts carried structured packets crafted to emulate internal system corrections. These were not chaotic disruptions. They mirrored legitimate latency adjustments used by distributed control nodes. Within Site Meridian's subterranean architecture, the packets were accepted as internal variance compensation. Microsecond timing, offsets compounded. Checksum validations remained intact because corruption occurred at the temporal layer. Missile battery coordination drifted fractionally out of phase. Above ground, the 4 S-300 missiles targeting the EA-37B entered terminal guidance. Inside Phantom Echo, operators initiated final defense logic. Rather than attempt total radar blindness, they injected falsified mid-course updates into the missile data link channel. The interceptors received 2 competing positional truths. At 4.2 nautical miles from impact, internal safeguards detected guidance contradiction and triggered self-destruct. 4 brief detonations punctured the night. Underground, consequences accelerated. At 3:24, hydraulic actuators controlling Site Meridian's reinforced blast doors processed overlapping operational states. Seal and cycle commands executing simultaneously due to corrupted synchronization signals. The doors halted partially engaged. Ventilation control arrays registered inconsistent pressure metrics. Backup turbines activated unnecessarily, producing transient load spikes across interior circuits. Operators inside the mountain perceived minor system irregularities. They initiated corrective diagnostics. They did not recognize that the network clock had been compromised at its root layer. At 3:25, the E-3 airborne command platform transmitted terminal coordinates to an inbound strike element approaching from the southwest. 4 F-15EX Eagle II aircraft, each configured with GBU-72 advanced 5,000-pound penetrator munitions, entered release parameters. They were not aimed at solid granite. They targeted structural vulnerabilities, partially engaged blast portals, ventilation shafts misaligned by corrupted pressure timing, tunnel geometries dependent on synchronized sealing mechanisms. At 3:27, release authority executed. 8 penetrators separated cleanly and began guided descent. At 3:28, impact. The munition struck compromised entry seams with meter-level accuracy. Rather than shatter the mountain, they collapsed access corridors and jammed structural interfaces already destabilized by internal desynchronization. Thousands of tons of fractured rock and reinforced steel folded inward. Ventilation shafts imploded. Blast doors froze permanently misaligned. Inside Site Meridian, structural integrity remained. Equipment survived. Functionality did not. Aircraft bays could not cycle. Missile integration labs lost controlled airflow. Command systems fell into protective shutdown as voltage instability cascaded through subsystems. At 3:31, American aircraft withdrew. No losses, no visual spectacle of total destruction. The facility still stood, but it no longer operated. At 3:35, Iranian operators confirmed what sensors could not mask. Site Meridian was physically intact, yet tactically neutralized. The strike had not relied on overwhelming kinetic force. It had relied on sequence, sensor suppression, deliberate exposure, electromagnetic manipulation, precision exploitation of compromised seams. The mountain remained, its purpose did not. By dawn, the Persian Gulf returned to apparent stillness. Civilian shipping resumed its quiet transit. Coastal lights dimmed with the rising sun. Externally, nothing dramatic marked the event. Internally, the equation had shifted. A $2.9 billion covert installation designed to survive direct assault had been disabled through integration of electronic intrusion and limited kinetic precision. The lesson extended beyond one facility. Hardened infrastructure can withstand impact. It cannot withstand corrupted timing. And in modern conflict, control of the electromagnetic spectrum determines which systems endure and which become inert while still standing. 8 penetrator munitions fell under satellite guidance calibrated to within 3 meters of their designated impact points. They struck without spectacle, no towering fireballs, no cinematic collapse. The effect was architectural. Shockwaves traveled through access corridors whose blast doors had frozen mid-seal. Ventilation shafts absorbed redirected pressure they were never meant to channel. Internal transit tunnels fractured at structural joints already misaligned by corrupted timing cycles. The mountain remained. The pathways inside it did not. At 3:29, Site Meridian's internal command grid began shutting down in segmented blocks. Not from direct obliteration, but from cascading protective responses. Aircraft elevator platforms halted halfway through their cycles. Unmanned launch shafts clogged with debris and pressure distortion. Primary data relays entered safeguard isolation as turbine generators detected anomalous voltage fluctuations and severed load transfer. The fortress was still there. It was simply inert. At 3:31, the American strike formation began coordinated egress. Every tail number confirmed. No losses, no emergency diversions. Behind them, a $2.9 billion subterranean installation remained physically intact beneath granite overburden. But it could no longer execute mission parameters. The strike had not erased the facility. It had removed its utility. 3:33 local time. Silence did not follow immediately. Inside Site Meridian, warning panels illuminated in waves across redundant consoles. Hydraulic inconsistencies, environmental containment deviations, communication latency mismatches between synchronized nodes. Individually, each alert resembled manageable malfunction. Collectively, they indicated paralysis. The complex had been engineered to survive kinetic assault. Reinforced concrete vaulting, segmented blast corridors, triple redundant independent power. It had not been engineered to survive compromised timing coherence. At 3:34, technicians initiated a controlled reboot of the central coordination server array. Manual override protocols engaged. The reset propagated unevenly. Packets traveled through fiber lines microseconds out of phase. Door actuators responded before full hydraulic equalization. Ventilation dampers received contradictory open-close states. Backup generators interpreted transient load shifts as fault spikes and disconnected automatically. The structure was hardened against impact. It was vulnerable to desynchronization. Above ground, Iranian surface-to-air batteries remained active. S-300 and Bavar 373 units continued scanning for renewed penetration. Reload crews operated under floodlights. Yet targeting stability degraded subtly. Fire control updates arrived in uneven intervals. Engagement radars briefly desynced from command nodes before reacquiring. Operators attributed the anomalies to residual jamming. They did not yet recognize that the internal clock framework governing coordination had been altered minutes earlier. At 3:36, US E-3 airborne controllers maintained distant orbit beyond engagement range. The aircraft that had executed the strike were withdrawing, but confirmation protocols remained active. Signals intelligence platforms monitored regional spectrum activity. Iranian encrypted channels surged with short-burst transmissions. Emergency routing between commands increased. The pattern matched damage control, not retaliation. At 3:38, the first full mechanical cascade manifested inside Site Meridian. An attempt to reinitialize a drone elevator sequence triggered a shaft pressure imbalance. Sensors falsely confirmed seal integrity. The lift engaged. Mid-ascent, mechanical resistance spiked. Hydraulic systems locked. Emergency cutoff activated. The elevator froze permanently. A launch complex designed to deploy unmanned systems across regional corridors now possessed a sealed vertical cavity filled with fractured debris. Elsewhere, partially engaged blast doors resisted manual override. Maintenance teams attempted mechanical crank access. Control displays indicated operational status. The doors did not move. Status lights glowed green. Steel remained immobile. At 3:41, Iranian cyber specialists conducted remote diagnostics. They identified no malware trace, no intrusion log, no foreign authentication token. The facility appeared uncompromised by conventional definition. It simply failed to execute commands reliably. Over the Gulf, Phantom Echo gradually reduced transmission output while maintaining monitoring posture. Mission objectives had been achieved. Prolonged exposure increased unnecessary risk. Inside the aircraft, electronic warfare officers observed persistent drift in Iranian missile coordination intervals. Command routing tables reflected timestamp irregularities inconsistent with baseline modeling. The seeded distortion endured. At 3:44, the final American aircraft exited effective engagement arcs. No American pilot had been lost, no emergency landing required, no direct dogfight recorded. Yet the covert installation embedded within granite had ceased functioning as intended. At 3:47, Iranian Air Defense Command ordered selective system power down to restore synchronization integrity. That directive carried strategic weight. Power down meant sensor blindness. Blindness meant temporary vulnerability. The facility had been built to withstand explosive force. It had not been prepared for invisible misalignment at the microsecond layer. The mountain still stood against the horizon, but its systems no longer responded as one. Power down meant blindness, even partial, even temporary. At 4:45 local time, Site Meridian remained electrically segmented, operating in fractured islands rather than as a unified command organism. The underground complex had been designed for siege resilience, compartmentalization, redundant turbines, fiber-isolated routing. Now, those same redundancies worked against it. Every subsystem required manual reconciliation. Every reconnection risked reintroducing the timing drift seeded earlier in the engagement. Engineers attempted phased restoration rather than full reactivation. One cluster at a time, one battery at a time. At 4:47, a limited radar calibration cycle resumed across a secondary S-300 battery positioned in an eastern valley. Operators aligned internal clocks using hardened quartz references rather than network-based synchronization. The radar image returned, stable, coherent, for 6 minutes. Then target track predictions began diverging subtly from passive optical confirmations. Not by kilometers, by meters. Enough to create doubt inside the fire control solution. Enough to force hesitation before launch authorization. In high-speed air defense, hesitation equals vulnerability. Inside site meridian, temperature stabilization efforts intensified. Ventilation capacity remained reduced by nearly half. Cooling units compensated unevenly. Drone storage racks registered rising thermal variance that threatened avionics reliability. The facility could preserve hardware. It could not project it. At 4:53, Tehran's Central Military Council convened an emergency encrypted session. The assessment no longer framed the event as a missile exchange. It was categorized as electromagnetic compromise with kinetic exploitation. That phrasing mattered because it acknowledged something uncomfortable. The strike had not relied on brute destruction. It had relied on manipulation of physics, timing, emission leakage, synchronization drift. Iran's defensive doctrine had anticipated cruise missiles. It had anticipated stealth aircraft. It had anticipated cyber intrusion through digital pathways. It had not anticipated corruption at the clock layer. At 4:59, the first internal estimate of restoration time was submitted. Best case, 72 hours for partial operational capability. Full synchronization, revalidation across all nodes. Weeks. Weeks meant deterrence gaps. Above the region, American ISR platforms widened their orbit patterns. Satellite imaging detected no outbound launch preparation from the mountain complex. No renewed radar coherence across primary engagement grids. Absence confirmed effect. At 5:06, U.S. command elements logged final operational closure. Strike aircraft secured. Electronic warfare platform recovered without incident. Rivet joint data archived for post-mission analysis. No celebratory tone accompanied the summary. Only metrics, target disabled, no losses, escalation threshold not crossed. At 5:14, Iranian engineers inside Site Meridian attempted full clock resynchronization using isolated atomic reference modules stored for contingency scenarios. For a brief interval, command routing stabilized across all sectors. Then, missile coordination nodes rejected upstream timing packets. A safety routine, designed to prevent spoofed guidance, isolated the network again. The system was protecting itself. From itself. By 5:22, sunrise approached the Zagros range. The mountain exterior looked unchanged under first light. No cratered slopes, no collapsed facade, no visible devastation. But beneath the granite, operators worked inside a facility that could neither launch drones nor coordinate integrated missile defense with confidence. At 5:31, Tehran ordered full operational stand-down of Site Meridian pending comprehensive forensic review. All offensive deployment authority transferred to alternate command centers deeper inland. That transfer was strategic admission. The $2.9 billion covert node had been reduced from spearhead to liability in under 40 minutes of engagement, not destroyed, neutralized. At 5:38, American policymakers received final classified brief. The phrasing was deliberate. The objective was not eradication. It was disablement. Achieved. The strike had demonstrated that hardened facilities could be rendered inert without leveling them. That fiber isolation did not eliminate electromagnetic exposure. That synchronization, the invisible heartbeat of modern warfare, was a viable target. By 5:47, international commercial traffic over the Gulf resumed its routine patterns. Oil tankers maintained lanes. Civilian radar feeds displayed normalcy. Publicly, nothing had happened. Privately, a deterrence equation had shifted. Because the message was clear to anyone studying the spectrum logs. The United States had not needed to penetrate the mountain. It had needed only to disrupt its coherence. At 6:02 local time, Site Meridian remained intact in silhouette against the morning light. Granite immovable, blast doors visible from satellite imagery exactly as before. But its internal clock, its capacity to coordinate force, was under forensic reconstruction rather than operational command. The unexpected strike had not announced itself with spectacle. It had unfolded in microseconds, in phase offsets, in electromagnetic seams. The mountain survived, its certainty did not. Its crew touched down just after first light, wheels meeting asphalt at a secured recovery strip far from public airspace. No applause greeted the landing. No press release announced success. The 7 specialists aboard Phantom Echo removed headsets, powered down consoles, and walked directly into debrief corridors where classified telemetry already streamed across encrypted tablets. They had not fired a missile. They had not crossed a visible border. Yet they had altered the operational balance of an entire defensive sector. At 4:52 local time inside the Zagros complex, engineers initiated a controlled restart sequence for limited unmanned aerial deployment capability. The command lattice accepted the request. Status panels illuminated green. Hydraulic systems pressurized along the primary drone elevator shaft. The shaft did not move. Pressure sensors reported nominal values. Motor torque indicators showed readiness. But alignment tolerances remained microscopically offset. The system believed itself synchronized. The mechanics disagreed. At 5:03, regional Iranian commanders shifted posture from active air defense engagement to containment and internal recovery. Radar emission rates decreased. Long-range batteries reduced tracking cycles. Mobile launchers relocated to defensive depth rather than forward projection. The strike window had passed, but the distortion remained embedded in the architecture. By 5:17, dawn crept over the Zagros ridgeline, pale light sliding across blast doors that were neither fully sealed nor fully open. Ventilation corridors carried uneven airflow. Heat accumulation in sealed sectors rose by incremental degrees. Technicians worked in rotating teams, manually recalibrating clock sources and verifying signal integrity down to nanosecond thresholds. The facility was not destroyed. It was compromised at its rhythm. It could be repaired, in time. But confidence could not be restored as quickly as machinery. At 5:32, American leadership received final confirmation through layered ISR channels. Satellite imagery showed intact overburden, no collapsed mountain face, no smoking crater visible to civilian optics. Signals intelligence indicated sustained troubleshooting traffic inside the complex, elevated internal comms, repeated clock reset attempts, partial subsystem isolation. The objective had never been spectacle. It had been proof that hardened concrete can be bypassed without drilling through it. Proof that fiber optic isolation does not eliminate electromagnetic consequence. Proof that physical depth offers no immunity against temporal manipulation. American force projection had shifted again, not away from kinetic capability, but beyond reliance on it. The strike fused electronic penetration, timing distortion, and precision ordnance into a single operational sequence. Destruction had been optional, disablement had been sufficient. By sunrise, the Persian Gulf appeared unchanged to civilian eyes. Oil tankers continued through established lanes. Patrol aircraft maintained routine altitude arcs. Commercial radar aggregators displayed uninterrupted traffic grids. But within regional defense ministries, analysis cells began rewriting threat matrices. Underground no longer meant unreachable. Air-gapped no longer meant untouchable. Synchronization became a strategic vulnerability. At 5:48, the final classified entry was logged. Target functionally disabled, structural integrity intact, no further strike required. No medals were pinned, no public acknowledgement issued, only recalculation, because the most consequential strikes are not always the loudest. Sometimes they are measured in microseconds.